Now we'll begin with lesson 4.1. Lesson 4.1 talks about forces. So forces is anything that has or changes an object's direction or speed or magnitude. So a force can be either a pull or a push. So if I have an object here and I push it, I'm applying a force to it, and I'm either changing its direction or I'm changing its magnitude. Now what you should know about a force is that a force is a vector quantity. Meaning what? Meaning that it has both magnitude, so magnitude plus direction. So you can't state a force without saying both the magnitude and direction, which is why it's represented with arrows, meaning that the magnitude is represented by the length of the arrow. So the length of the arrow represents the magnitude, and where it's pointing represents the direction. So if I have a small arrow here, I have a small magnitude pointing in the right direction, and if I have a larger arrow, a lengthier one, then it has a greater magnitude, and I could change its direction. What you should also know about forces is that the SI unit of forces is going to be the Newton, or symbolized with N. So forces can be categorized into two different categories. So one being contact forces, meaning that you're touching. So two objects have to touch to apply a force. So for example, when I push an object, I push it and I touch it and I make it move. Now, non-contact forces such as gravity is the other category. Or electric force, like for example, electricity passing through a cable. That's a non-contact force. So the types of forces we're going to go over during these lessons are going to be as follows: tension force, not in this lesson though. We have applied force, which is when you pull or push an object, which is contact obviously. We have normal reaction force, which is the force against gravity. So for example, this is gravity pushing, gravity is pushing an object down. Normal force will be the equal and opposite force against the force of gravity. We'll go into this in more detail. Friction force we're not going to be talking about at all. Same with air resistance. These are all forces that resist motion, which we won't be talking about. Gravitational force, which is gravity, we will be talking about it. It's a non-contact force, meaning that this does not require you to be touching it. Then we have magnetic force, not going to be talking about it, and electric force as well. So when we consider forces, it's important to understand how to identify them. So for example, when you have a person here and this person is kicking a ball, he wants to kick a ball, for example. It's important to, and he kicks it, right? So he applies a force. It's important to understand that the person and the ball are all in a system. What does that mean? That these people or these objects and person are exchanging forces. So everything inside the system are somehow interacting with each other, and everything outside the system, so outside, so which is like in this area, basically everything else is the external world. Now the person or the thing applying the force, so if I kick the ball, I am applying it and I am the agent. So I am the cause of this interaction. So if I have, for example, a table, so I have this table over here and I have a book on it, the applying forces are going to be gravity pushing it down and normal force pushing it back up. So this is a system. And the agent of this action, so I have gravity down, right? Normal force up. The agent of the system is going to be gravity because it's applying the force. It's causing this interaction. So what we should know about forces is that there are two types of forces when you apply it to an object. It can either be balanced forces and unbalanced forces. Unbalanced. So balanced or unbalanced. So say we have two different sides. We have the blue side and we have the red side. Red side is consisting of three different people. 1, 2, 3, and they all share a rope. And then the blue side as well, 3 different people. And they also all have a rope. And this rope is connected, right? And they're going to all, so both sides are going to pull this rope. Now, if they all exert, each person exerts 100 newtons worth of force. So they all exert the same amount of total force. So here it's 300 newtons on this side, and it's going this way. And here it's 300 newtons on this side, and it's going this way. What will happen to the rope? And my answer to you is that it will not move. Nothing will happen. Why? Because both forces cancel out, right? So when you have a vector in one side that's like, for example, 300 newtons, and you have another vector that's on the other side that's also 300 newtons, the forces of equal magnitude, so 300 and 300, but opposite direction, so this is going right, this is going left, they will always cancel out, meaning that nothing will happen. So when the forces are canceled out, that means they are a balanced force, meaning that when a force is canceling out, meaning that the net force, which is the total force on the entire system over here, is going to be 0. That means it's a net force 0 and it's a balanced force. Now, what if, for example, this person over here leaves? He decides that he doesn't want to continue anymore. The balance over here on the red side, it's going to be now, it's not going to be 300 here. The total forces here is going to be 200. So I have a total magnitude of 200 newtons on the red side, meaning that the force, the arrow actually is going to be a little smaller, meaning that there's less force going to the right side and the same amount of force going to the left side. But the total net force of this entire system is not going to be 0. It's going to be 100 to the right, 100 to the left, sorry. So there's going to be 100 newtons going to the left side, meaning that the total net force is going to be minus 100 newtons, minus being the left. So since the forces here aren't equal, so you have different forces of different values and different directions, it means there's going to be an unbalanced force. And in reality, the rope and the people are all going to go towards the left side, because there is a force on the left side that is greater than the force on the right side. So this is all categorized as an unbalanced force, and the whole system is unbalanced. Also, one thing you should know here is that the net force here isn't 0. The net force here is minus 100 newtons. How do we calculate the net force? We can calculate the net force by subtracting all the forces that are in different directions. What does that mean? So we calculate all the forces on the right side. So we have 100 newtons on the right side. So we can do it like this. 100, we'll do it in red. So right side is positive and left side is negative, right? So we add all the forces. So 100 newtons plus 100 newtons. And here we have minus. So we'll do it in blue here. Since it's negative, it's going to be minus. Each force here is going to go to the left side, so it's going to be negative. It'll be minus 100, minus 100, minus 100. And if you add all of this up, it's going to be equal to minus 100. And this is the entire net force. So the F net is going to be minus 100. So before we get into the last two ideas, it's important to understand one more thing, which is weight. So what is weight? Weight is equal to the mass of the object multiplied by the gravitational constant, or the gravitational force. So mass times gravity. And weight is also calculated in Newton. So N. So for example, if an object is 50 kg, to calculate its weight, you would multiply it by the force of gravity. Let's say we round it up to its 10. We round up gravity to 10. We would multiply it like this, and it would be 500 newtons. So this is the object's weight. It's important to know this so that we can get into calculations. So a quick introduction to an idea that we should understand is the normal force and there are three different cases, so we'll go through each case one by one. So the first case is, for example, if an object is on a table. This is a table, and there's a book here. It's it lays at rest on this table. So it's sitting on this table at rest. So what are the forces acting on this object? Well, I'll tell you that there are two forces and not one. Why? If there is one force of gravity or weight, there's one force, weight pulling it down, so which is m times g, then the object wouldn't just stay at rest. This is an unbalanced force. And what happens when there's an unbalanced force? That means the object is going to go in the direction of the unbalanced force. So it's going to continue going downwards as if there's no table. But that doesn't happen in real life, right? The object, if you put a book on a table, it'll stay on the table. Meaning that there's some kind of force pulling it back up, or counteracting the force of your weight, which is actually called the normal force. And it's equivalent in magnitude of the weight. And it is denoted by Fn. So F, force of normal. And it is perpendicular to the plane, or perpendicular to whichever direction or whichever kind of line the object is making it. So for example, if it's on a hill, it's perpendicular to the hill. Like if there's a ball rolling down, that means it's going to be perpendicular to the hill. If it's on a normal table, then the normal force will be perpendicular to the table. And it's important to note that. And the second case that you should know is, for example, when you're on a hill or an inclined plane. Let's take the hill example. And you're just on this hill, and you're gonna roll down. Not roll down, you're gonna slide down. You're on this cart here. It's gonna slide down this hill. It's gonna go downwards. The forces acting on this are obviously weight again, downwards. So your weight is going to go down. Let's draw the same arrow. Weight, so m times g. And then the normal force. But where's the normal force acting? Remember we said it's perpendicular to the plane. So it's going to be perpendicular to whatever surface you're on. So it's going to be perpendicular like that. Right, makes a 90-degree angle with the surface or the ground. So the normal force is going to go like that, and it's going to be equal to the weight. But why does the object move, right? Didn't we say that if it's equal, it's going to cancel it out? But no, that doesn't happen here, right? The object's going to slide down. And that is because it's not, the normal force isn't in the same direction. It is slightly towards this side, right? The normal force isn't acting, it's not like canceling out completely like this, right? It doesn't cancel out completely. It's canceling it out partially. So it'll slow down the movement of this object, but it won't stop it completely, which is what you see when you roll down a hill or you slide down a hill, right? You slide down the hill, but you don't stop completely. And the final case is, for example, when you have a rope, which is actually somewhat denoted as tension, but we can also take it as normal force. And you have a rope here, or we'll draw it with this, and you have an object. For example, you have a ball. It's like 2 kg. It's on this rope. And what are the forces acting here? You have gravity, right? Or weight downwards. So weight. And you also have a force keeping this object from moving, right? If I told you that the object is at rest here, hanging on the rope, then there's going to be an equal and opposite force, which is some denoted as tension, sometimes normal force, and it's going to cancel out the weight, and it's going to keep the object at rest. So you have normal force here, or tension, which is canceling out the weight and keeping the object at rest. So those are the three cases of normal force. We should be able to understand them and know how to identify them. So for the first question we're going to solve, it's going to be about a skydiver, and this person is falling downward through the air at a constant velocity. and the air exerts an upward force. So here it's stated that there is an upward force, so we should also consider it. So let's just quickly draw our skydiver. So this person over here, we can just draw a free body diagram. That's what we're going to do here. We want to draw a free body diagram. So there's like a parachute, right? It's like somewhere on him, and it's and he's falling downwards to the air. So what are the forces acting on the subject? So obviously there's gravity or weight of him. So we can say there's a weight downwards. So weight downwards. And there's also a drag force. Now, will the drag force, which is the force that is pushing upwards, right? Because if there wasn't a drag force, then this object would be in free fall. But it's not in free fall. There is a force acting on it, and it is called drag force. So is the drag force arrow going to be greater than the weight, or is it going to be less than the weight? So here it says it's falling downwards. That means it's not in equilibrium. It's not like this person isn't floating in the air. He's moving downwards, meaning that the downward force is going to be greater than the force contradicting it. So that means it's going to be a smaller arrow acting. So we can say it's the force, drag force, and it's smaller than the force of the weight, which is why this person is going to fall at a constant or velocity downwards, and that's why he falls. And that's it for the first question. Calculate the net force of the object knowing that it is in equilibrium. So for this question, it wants us to calculate the net force and knowing that the object is in equilibrium. So what does this mean? This means that the F net is going to be equal to 0. So if we know that the F net is going to be equal to 0, then we can calculate the net force. So first of all, we should know that we should calculate the y-axis alone and the x-axis alone. So we calculate these forces alone and these forces alone. So we can split this up into A, and then we can do B alone. So we'll do A first. So A says there is 90 newtons to the left, so it's going to be negative, positive, positive, negative. So to the left it's going to be negative. So knowing that, we can do minus 90, and then A here is positive, right? It's going to the right. It's going to be plus A, and then here 40 is also positive, so plus 40, and then equal to the F net, and the F net is 0, so 0. And then we just do the math, and A is going to be equal to plus 90 minus 40, so it's going to be 50. So 50 newtons. So A is equal to 50 newtons. Next up, B. So we have B upwards, so B is positive, and 10 positive, and then minus 70. So we can say that minus 70 plus 10 plus B is equal to the net F net, which is 0. Plus 70 minus 10, B is going to be equal to 60 newtons. Let's answer to B. So for this next question, it's basically the same thing, except it wants us to calculate the net force knowing that the object is moving at 40 newtons upwards. What does this mean? That means that on the y-axis, the F net isn't 0 this time. The F net is going to be equal to plus 40, so 40 newtons upwards. And it's at horizontal equilibrium, so this is the F net for y, so the F net for x, so the horizontal, is going to be equal to 0 still. So since we already know the F net of the x-axis doesn't change, we'll only do the y-axis. So here B is going to be equal to the F net, so 40 is equal to B, so positive, right? Positive, negative, plus 10, and then minus 70. And then if we do the calculations here, plus 70, minus 10, B is going to be equal to 100 newtons. That'll be it for lesson 4.1, the first part. There's going to be another part which continues this lesson relating Newton's laws to the ideas explained here.